Dave Tandy from AG Optical Systems. This video will describe how to collimate your iDK astrograph. You will need the following hex keys and the following collimation tools: a 2-inch Cheshire and a laser collimator, and the Takahashi collimating scope is optional. After receiving your iDK and unpacking it, spend a few moments going around the scope to ensure that all of the screws are tight. It's not uncommon for some screws to vibrate a bit loose, especially if the scope has had a rough ride while in transportation. The screws do not need to be gorilla tight. A snug tight is sufficient. The collimation adjustments on the iDK consist of 3 pairs of push-pull screws. The arrangement is the same on the primary and secondary cells. On the primary end of the scope, there are 3 lock screws. Be sure to back those out 2 or 3 turns, and 3 collimation screws. Do not adjust the black screw. On the secondary assembly, the collimation arrangement's the same. There are 3 lock screws. Again, be sure to back them out 2 or 3 turns, and 3 collimation screws. Do not adjust the black screw. On your iDK, it helps to remove the primary baffle to provide you with additional visual cues when collimating the scope. The primary baffle is attached to the scope at its base using a lock ring. Reach into the scope with one hand, grasp the baffle, loosen the lock ring, and once the baffle comes free, carefully remove the baffle from the telescope. On the 10-inch iDK, it also helps to remove the secondary baffle, as this will provide you with a better view of the spider vanes that need to be aligned while aligning the primary mirror. The collimation process consists of 3 iterative steps. The first step is laser align the secondary. The next step is to collimate the primary. The third step is to check secondary centration and, if necessary, adjust the centration of the secondary. This process is iterative, and you may have to go through it 3 or 4 times to get the scope well collimated. To start the process, insert your laser collimator into its adapter. To check if the laser is properly aligned with its housing, hold the laser firmly against the adapter and rotate it while observing the reflected spot at the center of the secondary mirror. If the laser collimator is properly aligned with its housing, the image of the laser spot in the secondary will not move when the laser is rotated. If the reflected image traces out an arc, then the laser is not properly aligned with its housing, and you'll need to adjust it or obtain a different laser collimator. After you've verified the laser collimator is properly aligned and is seated well in its adapter, move to the front of the scope and observe the laser spot at the center of the primary mirror. From the front of the scope, look down towards the center of the primary mirror and locate the reflected laser image and the spot where the laser is emitted. You will want to adjust the secondary screws to bring the reflected laser spot directly onto the laser aperture. Once you've done this, you'll want to move to the back of the scope, insert the Cheshire tool, and look through the Cheshire tool, and you will observe 4 pairs of spider vane reflections. You'll see one set of 4 in the inside narrow light ring, and a second set of 4 on the larger light ring. The idea is to adjust the primary to bring all spider vanes in line. Again, make sure when you insert the Cheshire that it's seated well against the face of the adapter. You'll observe an image identical to this one. You can see the inside narrow light ring and then the thicker light ring. The outside light ring is just looking past the secondary mirror outside the scope. To adjust the vanes at the 2 and 8 o'clock positions, you will adjust the primary collimation screw that's to the lower right as you're looking up through the scope. To adjust the opposite pair at about the 10 o'clock and 4 o'clock position, you will need to adjust the primary collimation screw that's to the lower left as you're looking up the back of the scope. Large adjustments are not necessary. Adjust the primary mirror until the 4 pairs of spider vanes are aligned. The next step is to observe the inside light ring. And if the inside light ring does not have an even thickness around it, this means that the secondary is not centered in the optical path of the telescope. So you will then need to adjust the secondary centration. In this case, you can see that the ring is more narrow at about the 3 o'clock position. So to make the ring evenly thick around its circumference, we will need to move the secondary towards the narrow side of the ring. So in this case, when you're looking up from behind the telescope, the secondary will need to move towards the right. To make this adjustment, move to the front of the telescope, locate the 4 screws that attach the front ring to the spider vane, and loosen the one that's opposite of the adjustment you want to make. You do not want to tighten or pull on a screw first because you'll put a lot of tension on the vane and could damage it. So loosen the opposing screw and then tighten the one that's designed to pull the secondary the direction it needs to pull. You may need to adjust 2 vanes at the same time to move the secondary in the desired direction. So now that we've adjusted centration, we repeat the process. We insert the laser, we laser align the secondary, we use the Cheshire to align the 4 spider vanes by adjusting the primary, and then we check for an even thickness inside light ring. Once you've accomplished this, the scope is well collimated. It may still need a few tweaks out under the stars, but it'll be very close. If you use the optional tack collimation scope, I suggest that you use it to help align the spider vanes and assess the light ring thickness, but when assessing secondary centration, use the Cheshire tool, as it's more easy to know which direction to move the secondary. And here's some notes. Don't assume the secondary mirror spot is perfectly centered. Use it as a reference to get you close. And be careful not to over tighten the screws, as you can damage them.